Today I will talk about our recently accepted paper at ICSI that Alberto and I will present next year in Canada. And so the topic of this paper was to inspect what is the impact of code review automation tools on the final code review from the reviewers. Why? Well, because in this year, a lot of approaches to support code review have been proposed, and the goal of these tools is to improve the quality, the general quality of the reviews, and to save time for developers. But we don't know if they actually do this or not. So to study the impact of automated code review tools, we conducted a controlled experiment involving developers, and what we want to do was to compare the reviews done from different developers in different treatments or scenarios, including or not the support of automated tools for code review. But let's start from the beginning. So first of all, we selected different projects, in particular 6 projects, both written in Java or Python. And in this project, we manually injected some issues. And then we asked the developers to review and find these issues. Of course, we do not just randomly added issues in the programs, but we leveraged this study from Mantilias and Lassenius, in which they studied the types and the distributions of issues found in code review. So we tried to have a realistic scenarios with the real distributions. Of course, not all the projects were suited for some issues, and as you can see, we have different numbers of issues in different projects. This is done, one, because the different projects have different lengths, different characteristics, but also to have a realistic scenario. So usually we don't find the same number of issues in each project. And here we have an example of injected issues. So this is a piece of code in one of the projects, on the Java project. So on the top we can see the original code, and on the bottom the modified one. So we can see that we replaced the string builder with a normal string concatenation, and so this can result in a degradation of the performance of the project. So then we defined 3 different scenarios for the code review. In the first one, we have a classic manual code review, so there is no utilization of a code review automation tool. In the second one, we have an automated code review, meaning that we provide the developer with an automated review on the code. And this is done by ChatGPT. So we provide the code to ChatGPT, and then we ask it to provide a code review. So it can be able or not to find the injected issues in the code, or maybe point out to some other quality issues in the code. Finally, we have the comprehensive code review scenario. In this scenario, we provide the developer with a review in which we point out all the injected issues in the code. This is a sort of ideal scenario for the code review automation tool. So we aim to reach this status, but of course this is not the case of today. And in fact, the review were actually manually written from us, and then we just asked ChatGPT to rewrite the review just to have something that can be similar to what a code review tool can output. So the developers will believe that the review provided is an automated code review. Then, so we have 6 different projects in 2 programming languages and in 3 different scenarios. So in total, we will have 36 different code review tasks. So for this study, we invited 82 developers, but of course, not all of them accepted the invitation. And in fact, only 40 developers accepted. But only part of them, 29 of them, actually submitted the review tasks. So in our study, we just included these 29 developers. So for each code review tasks, we were able to collect 24 data points. From these data points, we were able to collect not only the final code reviews, but also other informations. And for this, we leveraged the Taco tool implemented in Code Lounge. This tool is able to let us to control the behavior of the developers during the code review. So for example, we were able, Taco records the event such as the opening of a file or moving from a file to another file. And so we were able to have all the behavior of the developer during the code review. With this information, we tried to analyze and to compare the code review done in different scenarios. In particular, we focused on the quality of the review, so meaning the issues that they were able to find and to report in the final code review. Then we also analyzed the time cost of the review, so if there are differences when we provide an automated code review. As I said, the goal of these tools is to reduce the time cost of the reviews. So this is one of the key points of the analysis. And finally, also the confidence of the reviewer about the final review. In fact, we asked the reviewers, the participants, to provide a score about their review from 1 to 5. So first of all, we performed a general analysis on the final code review output. And we wanted to investigate if there are differences in the characteristics of the final code reviews. So here we can see the block spot comparing the code reviews in the different scenarios. So we have MCR, that is the manual code review, ACR, the automated code review, and CCR, the comprehensive code review. So how we can see, we have the number of reported quality issues. Here with quality issues, we don't mean the injected issues. So here we have the number of total comments, issues that points the code reviews. Then we have the length of the code review in sentences. And then the line coverage, the total line coverage, the comment, and the code. So as we can see, we have some differences, in particular in the number of reported quality issues and in the length. Instead, the coverage is more or less the same. So what we can see from this first analysis is that, yes, there are some differences. And in particular, we noticed that the code review output from the scenarios in which there is an automated code review, they are more verbose. So they are longer, and then can be maybe more complex to analyze from a developer, but in the same time they are covering more or less the same code lines. So next, we want to see if there is actually significant differences in the quality, as I said. So in the issues identified by the developers. And we can see that First of all, as we expected, of course, in the comprehensive code review, all the developers were able to identify all the injected issues. Of course, they were provided with a comprehensive code review pointing out all the issues in the code. So we expected this result. But what is interesting is that in both the automation code review and the manual code review, we have more or less the same situation. So they were able to find only half of the injected issues. But what is interesting is that if we look at the number of distinct lines covered in the final reviews, covered, I mean that they were lines commented by the developers, we can see that in the manual code review, we have a larger coverage of distinct lines of code. So, for example, in total, in the manual code review, the reviewers pointed out to 484 different code lines, while in the automated code review, the coverage is a significant less compared to the manual code review, and this is I mean, we explained this because maybe the reviewers are looking at the manual, at the automated code review, they tend to focus only on the line of code, on the part of the code where the automated code review is pointing. So the exploration of the code is less when we provide a code review, an automated code review. So then we also analyzed the time, the differences in time in the different scenarios. And what we found is that actually the automated code review, in the scenario with automated code review, the time increases. And this is probably due to the fact that when we provide an automated code review, developers spend time in reading the review, understanding the review, and then, of course, checking the issues in the automated code review. Moreover, we can see also that the variability of time in the automated treatments is higher. And maybe this is because the automated code review can have different length, can be more or less verbose, and also because maybe different reviewers, different developers can trust less or more the automated code review. So if I trust the automated code review, maybe I spend less time in checking the issues in the code review. Instead, others are not so confident with the code review tool, and so they spend more time in checking the review that they received. And finally, we also inspected and compared the confidence of the reviewers in the different scenarios, but we didn't observe any statistical differences in the confidence, in the final confidence. So what we learned from this study is that the code review automations at this moment are not able to provide a high quality code review, and more important, they are not saving time and they are not increasing the quality of the code reviews. So our suggestion in this case is that instead of using this tool as a primary source for the code review, they can be used, for example, after a first manual code review, and so they can more than find issues, they can use these tools to assess, to double check the manual written code review. And so with this, I conclude my presentation. Thank you for listening, and I'm here if you have questions.